Hello everyone, in this video I wanted to give you a little bit of information on the group project as well as give you a few tips on calculating these things using Excel should you choose to do so. So first of all, before I get into it, the group project can be found if you go into Canvas under group project. You can find it in a variety of locations or in this announcement where this video is posted as well. But anyways, there's a PDF. I strongly suggest you download this and read through every bit of this just to make sure you know what's up and know what the project is. But that should look something like this. And what I'll do is I'll just give you a quick walkthrough. I'm not going to go into all the details because you can read them, but just give you my 2 cents on everything. So basically what you'll be doing is you'll be solving an apportionment problem where there's a fictional college here where we have a bunch of students in each of our departments, and we want to know how many professors should each department get if we're fairly distributing professors to each of the schools. So, we can see that each department has a big variety in the number of students that they have. And, say we are giving out say we want to know, well, how much should agriculture get, 5 professors or 10 professors? And, art, 10 or 20. Basically we'll be doing apportionment and also looking at, as the years change, how should the distribution of professors change as the numbers either increase or decrease. And each group will be doing a slightly different set of methods. So basically, what you need to do is register your group in Canvas. Let me show you what that looks like as well. But basically, if you go to the Peoples tab in Canvas and you move over to Project Groups, there are a bunch of groups in here, basically, which are empty and ready for you to sign up for a group. What you can then do is take your name, drag it into a group, and sign up for your group in that way. If you need help finding a group, and if you don't, if you don't know anyone, or you just need, because this is an online class, we don't work together on a daily basis, and in the group project, it'll be very helpful to have other students to work with. You can go into the discussion board and make a post about group project and formulation and discussion. Looks like there's already a couple posts in here, but basically what you can do is just post a message in here, say, hey, I'm looking for a group, and you can reply to other people, get each other's emails and contact information. And when you're working on the group project, you can make your own Zoom meetings or discuss the project over email, or it's a lot easier to do it over voice. So what I recommend doing is try to, step 1, form your group, and step 2, figure out a time to meet. You guys can even meet during our normal class time Zoom sessions if you want to, ask me questions. But I'd advise that you spend a little time working on it before you come to me with questions, just so you can kind of get a sense of what needs to be done, and where you might be getting stuck on this project. But anyways, basically, once you find your group, again, you can use the discussion board to do that. You can work alone too if you really want to. There's no penalty for working alone other than just having to do a lot more work by yourself. Because in your group, you can divide and conquer some of the work. But basically, in that People Project Groups tab, you just drag each of your group names into that, and each one of you should be able to add yourself to particular groups. As you can see here, I can add you all to groups, but I'm not going to be assigning groups. It's all your choice. So anyways, back to this. What does that group number mean? Because if you notice in Canvas, there's a bunch of different numbers. And it doesn't really matter which group number you do. The only difference will be what methods of apportionment will be mandated that you do, and how many professors are you assigning. So basically, to give this problem a little bit of variability, everybody's using the same number of students, but each group will be doing a slightly different project because they're assigning a different number of professors. So in each case, let's say that group 1 has 350 total professors to apportion to each of the schools. Group 2 would have a different number, and so on. And also, in addition to using different numbers, you'll be using different methods, where each of those just stands for our 4 primary methods of apportionment: H for Hamilton's, A for Adams, J for Jefferson, and W for Webster's method. And I'm not mandating you do Huntington Hill, but you don't necessarily have to limit yourself to just those methods. You can technically do them all if you really want to be thorough. But, basically there's a mandated minimum amount of work um, for this. And again, what you can do is divide and conquer, split up the labor, and also this sort of math is a little bit tedious when you're doing it all by hand. And I wanted to show you guys how you can do apportionment in Microsoft Excel as well. So at the end of this video, after I wrap up my little explanation here, I'll show you how to use Excel if you do want to do this. I think it will make it easier. And when you're doing your paper write-up, it's a little bit easier to use Excel because then you can just copy paste in the spreadsheet files back into your Word document or whatever document program you're using. But you could do all this work by hand by making tables and then just take a picture and uploading that to your project as well. So how you show your solutions is up to you. Because there are quite a few departments and the data is pretty large. But anyways, in addition to actually solving the apportionment, there is the main component of this project is the write-up and the paper component. So I kind of get into what I want, but it should have the normal paper format. Basically, here's an outline of the different sections of your paper and what's what. As well, in the analysis of results, I want you to analyze things a little bit further than what we do with standard apportionment, because when you're comparing the different answers you might get from Hamilton's or Webster's or Jefferson's or Adams' method, I also want you to kind of look at the results and compare what are the differences in the class size and the relative difference, which it gets into what I mean by that if you want more in the paper. And I wanted to also mention in the conclusion, what I want you to say is what is your final decision, because you will probably get different answers depending on the methods that you use in the different years of apportionment. But basically how many professors should go to each department, what would be your final decision for the actual apportionment if you had to make that decision, and why, as well as just summarizing everything else. And your paper should be, well written, grammatically correct, titled, organized in a nice fashion. Obviously, you don't have to, go too extreme. Just obviously do what you need to answer everything that I said. But another thing that I think is kind of important that I wanted to just emphasize is that I want you to be writing this paper not to me, because a lot of times what I get with group projects is the students are writing their paper. They're writing it basically in a voice where they're speaking to me. So they're kind of assuming that the reader knows what apportionment is and understands the math that's going on. But what I want you to do is not do that. I want you to write it towards not necessarily someone who's uneducated, but someone who may not understand the math of apportionment and these differences. So basically, summarize the differences in your methodology and really explain it to the best of your ability. You don't necessarily have to go into every individual calculation, but I want you to try to summarize the differences in the methods and explain the math that's going on to someone who is not educated on apportionment math. And try to be as clear as possible with your explanations. I know explaining math is not necessarily easy, but again, do your best, and that's all going to be part of the grade. It's going to be based on, well, are your solutions correct? Because there is a correct answer. Obviously, the final decision is not. There's not necessarily a black and white answer, but when you're doing Jefferson's method to solve this X problem, there is an answer. So what I'll be doing is we'll see, okay, was all your apportionment correct? And then is your paper well written, and is it properly explained? Did you actually explain the math you did? Can I follow along with this? And again, try to write this paper so that someone could just pick it up and read it, having little information about what's going on. Also, in the introduction, one thing that I would like you to do is try to explain what you're doing. Even though I know what the project is and you do too, try to, again, write the paper in a way so that someone could just pick it up and understand what's going on. That's kind of the goal of this. So say, for example, in 10 years, you were to go back and look at this paper, you would kind of know what it was about, and the introduction kind of gets into that. And that's really the purpose of the introduction. The method of solution is just explaining the methods that you use in actually getting into your answers and your math, with the analysis getting into more detail. as well as providing the explanations. Uh, and you can organize it how you want. You don't have to do it exactly as I say. But this will give you an idea for where to go. With your conclusion kind of wrapping everything up and saying, well, what do you think the answer should be? And bibliography, if you're using any websites or textbooks or whatever, um, other than our book, I mean, you could reference our book too, um, in that if you're looking for something to put in your bibliography. Anyways, in this project, the deadline has changed from the initial schedule because I got this posted a little bit later than I had originally intended when I designed the summer class. So it will be due on the 8th at midnight. And again, feel free to drop in to Zoom. You can ask me questions if you're stuck or if you need help. Just please stick to your group. Do not work with other groups. This should not be really corroboration amongst the groups. And that's the point of your group, is to work together in that community as well. Anyways, that will wrap up the introduction to the project. Now, let me do the other thing I wanted to do in this video is give you a few tips on how to actually do math using Microsoft Excel or a similar spreadsheet program. Just if you're interested. If you want to do this, please feel free. And so what I wanted to do is let's return to some of the examples from class, and I'll just show you how you could do the apportionment with Excel instead of by doing it by hand. Like for example, what we'll do is we'll take the example where we're trying to give out scholarships to the different departments, and I'll just show you how you could do it in Excel using some of the methods. And really, it's just so that we don't have to do all this elaborate math by hand, because in a larger problem like this one, doing it by hand is quite tedious. And you can, if you're comfortable with that, that's totally fine. I don't care. But anyways, let's just jump into Excel. So let's start with Hamilton's method. Let's say we wanted to figure out how many scholarships would go to these departments by Hamilton's method. And we already did this in the videos and in the lecture notes, so we can reference our answer from before. But basically, what you could do is what you want to do is start by putting each of the populations in Excel in a spreadsheet. And organization I think is key in Excel. You could also use Google Sheets or Numbers or whatever spreadsheet program you have on your computer. But Google Sheets is a free option, which is just like Google Docs, but they have their own. If you already have a Google account, you can just access Google Sheets for free. And it's basically the same thing, basically just a ripoff. Well, maybe that's not the right word, but anyways, the goal, if you've never used Microsoft Excel, that's kind of what this video is for. If you're already familiar with it, you probably don't really need to watch the rest of this. But basically, it's just a program which allows you to put a bunch of data in. And also, really, the main value of this is not just an organization, but it also allows you to do a lot of mathematical calculations if you know how to tell it to do that. And that's what I wanted to show you, is how to do that. So what I would start off by, we could put in each of the departments: biology, business, religion, art, nursing. And basically I'll also put their populations below. And you can organize your table however you want to, but I tend to like to do them in rows, like horizontally rather than vertically, as it appears in the packet. And there was 80 students in the nursing department. And I'll go ahead and label what each of the rows mean as well, just to be thorough. And also what can be helpful is a total column, as we know. And one way to do the total is you could just manually add them all up, or since I had them here, that's fine. But I wanted to show you can actually do totals in Excel too. So if you use the command equals, and basically, when you're in a cell, you can enter whatever you want. But starting with an equals sign tells Excel that you want to do a mathematical calculation, and you can use certain formulas like what we call the sum function to actually add things up. So in Excel, if you do equals sum, and then you need to put a parentheses because it's like a function which tells it what to do, you can then tell it to add up a bunch of cells. And if I then select all these cells by clicking and dragging, you have to hold the click as you drag, you can tell Excel to add up all of those cells, which are the cells from B2 to F2. And Excel uses a column row based moniker system to label the cells, where each column is a series of letters and each row is a series of numbers. So B2 references a specific number, and this would be C2, D2, E2, F2, and what all this means is that it's going to take every cell between B2 and F2 and put them all together. And then if we close the parentheses, that's a way of telling Excel to add up all of that stuff. And basically we can get the total in Excel doing exactly that. But anyways, from here, well, our goal is to solve an apportionment problem, and we could use any of the methods. Let's just say we were starting with Hamilton's method. Well, Hamilton's method, we're always going to start with the standard divisor. So one thing I might want to calculate is, well, what is the standard divisor? And I'm just going to put it over here. Let me make this a little bit bigger, just so you can see it a little bit better. But that's always the total population divided by the number of seats. So here we have a total of 800 students, and we were trying to apportion 20 scholarships to those. So basically what we get is a standard divisor, and then we use the standard divisor to calculate the standard quota. So what I could do in the next row is list all the standard quotas, which would be basically the each student in the biology department divided by that number. And that's what I want to do next. And again, you could do all these calculations by hand, but this is the point of Excel, is Excel can do math, and it can use the numbers that we've already put in as pre-existing variables or values. So basically, let's say I wanted to do 241 divided by 40. How I do that is I start with equals, because that's what tells Excel to do math, and I can actually take a specific number and tell Excel to divide by another number exactly like that. And what that will do is it will take 241 divided by 40. And notice that it uses these colors to help, for those of you that aren't colorblind, to help see, well, which cells are being divided here. But I can make sure I'm doing the population divided by the standard divisor. And that would give me the standard quota for each as well. Excel has another feature which actually allows you to copy formulas. So let's say I wanted to replicate that formula to each of these cells, because each of these cells I'm going to do the same thing. I'm going to take the this value and divide by the standard divisor, and so on. And basically, if you look really closely, it's kind of hard to see here, but notice that in the bottom right corner, there's a little dot or a little button that is a little bit bigger, or there's a little square button right there. And if I move my cursor over that, it changes to this other plus symbol. And basically what this symbol does is it copies a mathematical formula. And if I click and drag this to the right, what it will do is it will copy that formula to the cells over it. And actually, notice how I did this. I'm coming up with this error, which is the division by zero error, because I didn't quite set that up right. But basically, if I make a simple adjustment to this formula, it will fix it so that it will work. And there's a reason it's not working here, and I'll try to explain that really quick. But basically, what it's doing is, if I want to divide by this number every single time, what I need to actually do is add some dollar signs around my I2 number. And basically, how Excel copies formulas is, as you're copying the formula, it shifts the numbers that are being used. And if you don't tell it to use the same number every time, it's going to have problems, as you saw. But basically, when I add these dollar signs to my formula, like this right here, what that will do is it will tell me to take this element and divide by I2 without changing it. And basically now if I click and drag this formula, it will copy that formula. If you look at these other cells right here, notice that the denominator had not changed. Oh, and this is another thing. If you're an Excel newbie, you can always see what calculations are being done by looking at this top line right here. So again, I'm sorry that this is kind of small on my recording, but basically the cell has the final answer, the final calculation that you want to have happened. But at the top here, you have an actual formula, which is kind of like, well, what's actually going on to do that? And if you click on it or highlight it, you can actually see what cells are being used. And notice that if I go over here, when I copied that formula, it changed the initial value, the numerator, but since I used dollar signs on the denominator, that value, we want to divide by the standard divisor every time. And to ensure that that happens, if you just put dollar signs around I, in front of I and in front of 2, it will make sure to not change it as you're copying formulas. And if that's all too confusing, or if it's I'm getting into a lot of technical aspects of Excel right now, you can do them all manually too. I'm just trying to give you some tips to make your life easier. But anyways, what we end up with is the standard quota for each um, each of the departments. And basically, this is not our answer, right? Because the issue is, well, we're trying to figure out how many scholarships, and these are not whole numbers. So, well, if we're using each method will be a little bit different, but if we're using Hamilton's method, we start with the lower quota, and we round each down. Again, you could round them all manually, but Excel has a feature which is called round down, which will automatically round down the any cell you want. So what I could do with the lower quota is to just take the number above and tell it to round that down. Now, when you're doing a mathematical function in Excel, you can actually get more information about how it works by, notice how right down here there's this like button that pops up which says round down. If I click that, it will go to the help menu and it will help me understand how this function works better. But if I'm looking at it, notice that it says round down, it's going to round down a number, and then it needs a second entry, which is how many digits to round it. But basically, this is very helpful with apportionment, is when we're rounding down, we're rounding off to the nearest whole number, and to basically round it, you want to use 0 decimal places when we're rounding because we're trying to get a whole number. So what you need to do is do round down the number, comma 0. And what that tells it to do is basically we'll just round it to the nearest whole number, 6. And if I copy this formula across, it will round each of those other ones down to the nearest whole number. Now, if you were wondering what happens if I change this, basically if I use round down of the entry, comma 1, what that will do is it will round it to the nearest 1 decimal place instead. And it didn't do anything there because it already was a whole number. But notice, you can tell Excel to round however you want to, but we want it to round to the nearest whole number, which is why we want to use round down B3, comma 0. And then, of course, we could find, well, what's the total? And so, here I want to find the sum of all those, right? Because when we're using Hamilton's method, we're never giving out enough seats, and we were too short here. And then I could even make another cell over here. So what's the surplus? Again, you can arrange these however you want and do the calculations however you think makes sense, but this is just how I would do it. And in this case, we were supposed to give out 20 seats, and we actually gave out 18, which means that we had 2 to give out, and we want to distribute those surplus seats to the states with the largest residue. Now, another way we could actually do the residue for Hamilton's method is, well, we have the standard quota and we have the lower quota. The residue is just the difference between them, right? Because the residue was, well, what's the decimal place that we had cut off when we rounded? And what we can see is that it's the residue is very easy to calculate if you just take the difference of those two numbers. So all I did was I subtracted them and I copied the formula over there. Now I can see each of the residues, and since it's Hamilton's method, we want to give out 2 surplus seats to the largest 2. Now there is a way to program Excel to do all of the surplus calculations for us. That's actually really complicated and is going to be way too hard to get into. So what I would suggest for Hamilton's method is just do it manually. You don't necessarily have to do all of this, but Excel is just nice for organization. And if you're trying to upload your data into a paper, you can just copy paste this into a Microsoft Word document, and then it should work pretty easily for making your write-up nice and pretty for those who are going to try to make it look really nice. And really, you don't have to necessarily spend a lot of time making your paper look nice. It's up to you, because really what I'm more focused on is the solution, the explanation. The bells and whistles are not necessary, but I know some of you guys are want to do your best to make it presentable, and this is kind of a nice way to do it. Anyways, and then I know that the Hamilton apportionment will be the lower quota plus the distributing out the surplus seats to the highest residue. So bio will not get a surplus seat, business will, religion will, art will not, nursing will not. And I can get my final Hamilton apportionment. Let's add those back up and make sure it works out, right? And of course, Hamilton's method always will work. And there we go. And you could bold them or do all sorts of things to show your work or whatever. But anyways, this is how you could do Hamilton's method in Excel. And another beautiful thing about Excel is if you want to change it up, you can just, like, for our project, we're doing it with a couple different data sets. You can just reuse the same layout, change your data, and kind of not have to rebuild it every single time you do it. And it will save a lot of time if you do this with the project. Well, if you're familiar with Excel, it shouldn't be too bad. If you're new to Excel, this probably will take more time, but I promise you, Excel is a skill that's worth learning a little bit of, because a lot of jobs require or use Excel, and a lot of times students don't really have much experience with it. So, anyways, I wanted to show you how to do a modified divisor method as well. So let's say that you wanted to use Jefferson's or Adams or Webster's method or something else. And you wanted to do that in Excel as well. In the same exact way, you could start with each of the standard quotas, and what will be different is, well, you're not necessarily going to be using the lower quota, it's going to depend. So I'm going to pick Webster's method just at random and say we're going to find this apportionment with Webster's method instead. Well, Webster's method did not use the lower quota, it used the rounded quota because, we rounded conventionally for that method. So instead of rounding them down, in Excel, if you just hit round, that will round to the nearest whole number instead. And round up is what, like how round down rounds them all down, rounds up rounds them all up. So if you're doing Adams' method, you want to use round up, Jefferson's round down, and Webster's just use the command round. And notice how that will change my outcome. And in this case, Webster's method, the standard quota did not work because the rounded version of the quota was 21. So we had to do a modified divisor, and our goal is to find a suitable divisor. So basically in Excel, what you can do is over here, what we did is we guessed the modified divisor. So as you're working with a problem, you could say, well, let's use a new column here and let's check a particular modified divisor. So let's say I'm going to set my modified divisor equal to, well, in this case, we gave out too many seats. So we want to raise the standard divisor so that it gives out less. Let's say we wanted to guess 41 for our modified divisor. Basically, it's really easy because I'm just going to take each of those numbers and divide by my new guess. So it would be, well, let's say my modified quota 1, just for my first guess, would be the biology department divided by my new guess. There. And again, I'm going to use dollar signs around my J5 in front of each the J, before the J and the 5. That will make sure that I'm going to use this every single time. And then I can drag that formula over like this to find each of the modified quotas. Then what I want to do is find the rounded quota. And actually, since I want to do the exact same math I did here, I can actually just copy paste that whole calculation. Actually, no, I don't want to do that because it didn't use the right cell. You can also copy paste things, and there's a lot of other features in Excel, but I want to round this one to the nearest whole number, so round comma 0. And I want to round conventionally, which is why I'm just using round here. And basically, I could see, well, does this new modified divisor work? And I could actually drag my sum down so I could see, and I could say, well, okay, 41, if I'm rounding them all conventionally, that did not work. And you could keep doing this, but actually another thing you can do is you can just keep tweaking the divisor and it will update each of those numbers that is done. So instead of having to redo all of division over and over and over again, you can actually just check a new divisor by taking the cell and changing it. So I could see, well, 41 didn't work, 42 didn't work, I could try 41.5, and eventually I could come up with, well, what is a suitable divisor, and then find my official Webster's apportionment after all is said and done. And if you want to include your Excel sheet as part of your project, that would be awesome too, because then it will make it a lot easier for me to check your work and check your math out. But again, that's all optional, but hopefully you can see the value in Excel in doing apportionment, especially with more and more data. Let's go ahead and wrap this video up. This is getting very long, but feel free to bring any questions that you have into Zoom or email me or whatever, and go ahead and get started. Let me know if you need anything. See y'all.